Day 782 of doing a LeetCode problem every day until I get a job. All right, y'all, we're back again another day, another LeetCode problem where we're doing daily LeetCode problems. And today we have question number 3019, number of changing keys. The difficulty level is easy, but don't worry because you already know we're going to keep the solution as simple and easy to understand as well. But before we get started, y'all, don't forget to like, hype, subscribe, comment, and share. And if you need any new Apple AirPods, go ahead and check out that link in the description so you can get you some. Now let's see what the question says. You are given a zero-index string S typed by a user. Changing a key is defined as using a key different from the last used key. For example, the string AB has a change of value while the string S equals a string B or lowercase b, uppercase b, lowercase b does not have any. Return the number of times the user had to change the key. Note, modifiers like shift or caps lock won't be counted in changing the key. That is, if a user typed the letter A and then the letter capital A, or excuse me, if the user typed the lowercase a and then the letter capital case A, then it will not be considered as a changing of key. All right, y'all, so that may seem a little bit confusing at first, so let's go ahead and take a look at these examples just to make sure that we are doing this problem correctly. So, in example 1, we had our input S equals a string lowercase a, capital case A, lowercase b, capital case B, lowercase c, capital case C. The output is 2. Explanation says from S of 0, which is lowercase a, to S of 1, which is capital case A, there is no change of keys as caps locks or shift is not counted. So right here, these two, when we go from this key to this key, there was no change because they're both A's. Even though one is capital and one is not, it doesn't matter. We don't count that as a change because it's the same character. So boom, then we go from S of 1, which is a capital A, to S of 2, which is a lowercase b. There is a change of key. So now we're going from this capital A to this lowercase b. Now these are two different characters, so that's a change of key. That counts as a change of key. So let's just come over here. That's one change of key. Boom. Then we go from S of 2, which is lowercase b, to S of 3, which is capital case B. There is no change of key as caps lock or shift is not counted. Boom. So now we go from here to here, and similar to A, when we go from B, lowercase b, to capital case B, that doesn't count as a change of key, so we don't add anything to our count over here. Boom. Now we're going to go from this B to this C though. So we're going to go from S of 3, which is capital B, to S of 4, which is lowercase c. There is a change of key. So when we go from this B to C, that's a change right there. So we could just add one. Sorry, y'all. We come right here, and we could just add one more to our count over here. Boom, y'all. Then we're right here, and we're going to go from S of 4, which is lowercase c, to S of 5, which is capital C. There is no change of key as caps lock or shift is not counted. So once again, we're right here with the two C's. This is not a change of character. So in the end, we just had two changes. 1 plus 1 equals 2. So that's how our output is 2, y'all. So just in case that didn't make sense, let's take a look at example 2. So in example 2, our input S equals a string capital A, lowercase a, capital case A, lowercase a, capital A, lowercase a, lowercase a, capital A. This time the output is 0. It says there is no change of key since only the letters lowercase a and capital case A are pressed, which does not require a change of key. So in this case, as you can see, all of the letters are the same, and since all of the letters are the same, there was no change of key, so we return 0, y'all. So boom. Hope that makes sense to y'all. And now that we understand the question, let's get into the fun part of this actual solution. Now, the first thing we're going to do is we're going to convert the string to lowercase so that uppercase and lowercase versions of the same letter are treated as identical. So we're just going to declare a variable called str, and we'll set that equal to s dot lowercase. Boom, put the parentheses. Then we need to track the number of times the character changes from one position to the next. So we'll come over here, declare another variable called count, and we'll set that equal to 0. Then we need to store the first character as the initial previous character, or the previous character. So we'll declare a variable called last, and we'll set that equal to str.first. Boom. Now we need to iterate through every character in the string. So we're going to say for char in str. We're going to open up the brackets. And if the current character is different from the previous character, a key change occurred. So we'll say if char exclamation point equals, so does not equal last, we'll open up the bracket and we'll say count plus equals 1. Then we'll come under this and we are going to set last equal to char. So we're going to update the previous character for the next iteration. Then finally we need to return the total number of key changes by coming right here and we can say return count, y'all. Boom, that should be all she wrote. Let's give it a run. Let's see, clean this up a little bit. It's a little messy, y'all. Sorry about that, so y'all can see better. Boom, now let's submit it. Make sure it still submits. And look at that, y'all. 3 milliseconds beats 17.65% of users. We could get that up. But for now, we just want to be able to solve the problem that is presented to us. And I feel like this is a good solution for that because it's easy to understand. And if you don't understand the solution, then you probably didn't learn anything. So that's why the solution is important. Now, with that being said, y'all, I hope y'all learned something today. And I hope to see y'all here tomorrow for another day, another LeetCode problem. See y'all then.